All right, so we are going to take a look at the special right triangles here. Let's get rid of this stuff up here. So this builds nicely out of the intro activity we did where we were looking at the patterns in the 45, 45, 90 and the 30, 60, 90 triangle. And so that's kind of the whole point, is that we don't have to use the Pythagorean theorem to solve these types of triangles. There's nice patterns that develop once we try enough examples, and that's why I had you guys try the exercise in your groups before we looked at the notes. So these are called special right triangles. There's two kinds. The 45, 45, 90 is the first one, and the 30, 60, 90 is the second one. And that describes the angles in the triangle. The first one is going to be a triangle with two 45-degree angles and a 90-degree angle. The second one is going to be a right triangle that has a 30-degree angle, a 60-degree angle, and obviously a 90-degree angle. And like I said, these are the celebrities. Look at that. They even have their own star in Hollywood. How cool is that? All right, so the first one, the 45, 45, 90. Notice, because the two angles are congruent, it's an isosceles triangle. Across from those base angles, the legs would also have to be congruent. So this is what I call the isosceles, not what I call, it is the isosceles right triangle, aka the 45, 45, 90 right triangle. Both of the legs have the same length. Let's use the letter L for the leg. And if you remember from the activity that you did, if you tried it enough times, you probably saw that the length of the hypotenuse across from the right angle was always the square root of 2, rad 2, times the length of the leg. So in other words, L times rad 2, or in other words, L rad 2. And that's it. You don't have to use Pythagorean theorem every single time. Okay? If you did, you would still get the same result. Okay? So let's try a couple. First thing you'll always want to do is label your sides L, L, L rad 2. Okay, I see a 90, I see a 45. In order to add up to 180, that means the missing angle has to be 45. Both of the legs have to be congruent since it's isosceles. One of the legs is 8. The other leg has to be 8. The hypotenuse is L times rad 2. Since L was 8, in for L, I'm going to substitute 8. And so the length of this hypotenuse is just 8 rad 2. Okay. For the second one, notice they didn't give you 45-degree angles, but they did mark the two acute angles with an identical swoop mark. So I know that this is an isosceles right triangle. If those base angles are congruent, then the sides across have to be congruent. If it's an isosceles right triangle, it has to be a 45, 45, 90. In this case, they're telling us that the length of the leg is 4 rad 3, so both of the legs have to be 4 rad 3. The hypotenuse is the length of the leg times rad 2. And in this case, we don't have a whole number for the side length. We have 4 rad 3 is given. So in for L, I'm substituting in 4 rad 3. I'm going to do the multiplication up top here. 4 rad 3 is my L times rad 2. And now I'm going to multiply the two radicals together. Rad 3 times rad 2 would give me rad 6. So this would be 4 rad 6 for my hypotenuse. For the third one, same thing we saw in the first problem. If there's a 90 and a 45, the missing one has to be 45 for the angle. So I know it's an isosceles right triangle, 45, 45, 90. The legs are both L. And what you'll notice in this one is they're actually telling us the length of the hypotenuse. This time we have the L times rad 2 side. And you could do this by pattern recognition, or you could do it as an algebra equation. But I think it's a little bit easier in this one to just compare the two sides. The left side is 8 rad 2, and the right side is L rad 2. The only thing that could go in for L that would make the two sides match is an 8, right? They already have the same rad 2. This number in front is 8, which means this L in front would also have to be 8. The other way you could do it is divide both sides by rad 2, and the rad 2's cancel out. So you're left with L equals 8. If that leg is 8, then that leg also has to be 8, since the triangle's isosceles. Okay, next one. Don't be surprised if they spin the triangle around. It will not always have a nice diagonal looking hypotenuse. In this case, notice the hypotenuse is actually on the ground, across from the right angle. Legs congruent means base angles have to be congruent. Both of those have to be 45. I'm going to label L, L, and my hypotenuse is L rad 2. So I get L times rad 2 equals 5 times rad 6. And in this case, I want to solve for L. Naturally, the first thing to try would be to divide both sides by rad 2. And that'll be a nice trick as long as the number on the other side, if it's under a radical, is divisible by 2. So if I divide both sides by rad 2 in this case, I get L by itself, which is the goal. I'm trying to find the length of the leg. And because 6 divides by 2 nicely, and both the 6 and the 2 are under a radical, one nice property of radicals, just like with multiplication, if you multiply 2 rads, you can multiply the 2 numbers underneath the radical together. The same thing works with division. If you have 2 numbers inside radicals, you can divide them. 6 divided by 2 comes out to a nice clean 3. And so this would give me 5 rad 3 for L. And we'll look at the case where it's not a nice divisible number, a little extra trick for something like that. Okay, take a look at number 5. 90, 45, missing angle, 45. Do your labels, L, L. In this case, they're telling us the hypotenuse is 5. Notice it's not 5 rad 2 or 5 rad 6, just 5. And so for something like this, if you try to do the same trick we had before, you're going to end up getting 5 over rad 2. Mathematically, you could type that into a calculator, but this is not considered simplest radical form. We have a rule in algebra that says we don't want to leave radicals in the denominator. No. Okay, it's almost like leaving a fraction unsimplified. It's not considered simplest form. So thumbs down, denominator is bad. We don't want to have radicals in the bottom. We want to make sure the radicals stay in the numerator. The easiest way to fix this problem is to multiply both sides by rad 2. And you might be thinking, wait a second, the opposite of multiplication is not multiplication. And that's true. But the point of doing this is because I'm strategically multiplying by rad 2 so that the radical goes away. Anytime you multiply a radical by itself, it ends up coming out to the exact same number without the radical. So for example, rad 2 times rad 2 is rad 4, but that's just rad 2. Try it with a different number. Rad 5 times rad 5 would be rad 25, but rad 25 is just 5. So when I multiply a radical by itself, the radical goes away. And so taking it back to my equation now, I multiplied both sides by rad 2, so the left side is 5 rad 2. On the right side, notice rad 2 times rad 2 is just going to turn into normal 2. And I still have L, but the benefit is now I got rid of the radical next to my variable. So now, solve it like a normal equation. To get rid of the 2 that's being multiplied by L, I'm going to divide both sides by 2. And so I get L equals 5 rad 2 over 2. And you want to make sure that the coefficients in front, the 5 over 2, is simplified. In this problem, it's a nice simplified fraction. If it wasn't, you'd want to make sure you math frac that. So this would be 5 rad 2 over 2. And then since it's a 45, 45, 90, the other leg also has to be 5 rad 2 over 2. So that kind of sums up the 45, 45, 90. The other special one that you saw in the intro activity was the 30, 60, 90. The side across from 30, just so we're clear on different side lengths, is the short side. The side across from 60 is the medium side. And then, of course, the hypotenuse is going to be the longest side of the triangle. Okay. And that just goes back to chapter 5. The shortest side has to be across from the smallest angle. The second shortest side has to be across from the second smallest angle. And then the biggest side has to be across from the biggest angle. We're always going to start with the side across from 30 as our short side. I always call that home base because you can always go from the 30 side, from that short side, you can always go to either the hypotenuse or you can go to the medium side across from 60 using 2 different rules. And if you remember from the intro activity, what you guys were noticing was that to go from the short side to the long side, so if I want to go to the side across from 30, and get to the hypotenuse, all I need to do is multiply that short side by 2. So I'm going to call my short side L. Okay, that's going to be the side across from 30. To get to the hypotenuse, all I need to do is multiply that length by 2. So this hypotenuse would have a length of 2 times L. Okay. So I'm going to label 90 as, let me get rid of this here. Get rid of my 90, or sorry, get rid of my comment here. Across from 90, the hypotenuse is going to be 2 times L. And again, what is L? L is going to be the short side across from 30. How do I get to the medium side? Going from short to long, I multiplied by 2. To get to the medium side across from 60, I want to take my short side, which was L, and that magic radical that showed up on the intro activity was rad 3. So I'm going to multiply the short side, L, times rad 3, and that gets me to the side across from 60. So the medium side across from 60 is always rad 3 times the short side. In other words, L rad 3. Okay, so 2 different routes we can go. Let's find some missing lengths. We're going to label just like we did for the 45, 45, 90. For the first one, across from 30 is my home base. That's my L. 60 at the top. Across from 60 is L rad 3, which in this case, if L was 10, then I'm going to substitute in 10 for L. This side across from 60, my medium side would be 10 rad 3. To get to my hypotenuse from the short side, I want to do 2 times L. Since L was 10, if I double 10, I end up getting 20. 2 times 10 gives me 20. Okay. So hypotenuse is twice the length of the short side, and the medium side across from 60 is rad 3 times the length of the short side. In number 2, we have a 30 and a 90. In order to add up to 180, that missing angle has to be 60. Label, home base is across from 30, that's L. Across from 60 is L times rad 3. And in this one, they gave us the hypotenuse, which is 2 times L, 2 times the short side. Nice, easy equation to solve for L. If I want to get L by itself to get the short side, I'm going to divide both sides by 2. 2L equals 14. Divide by 2, divide by 2. Tells me the short side across from 30 has to be 7, which would make the side across from 60 7 rad 3. We got L was 7. Now I take my 7 and I plug it in for L on the medium side. So this would be 7 rad 3. For the third one, we have a 90 and a 60. Missing angle needs to be 30. I'm going to label across from 30, my short side is L. Across from 60, my medium side is L rad 3. And across from 90 is 2 times L, 2 times my short side. For number 3, if I look at the side across from 60, that's going to be kind of where I want to get started because that's where I have my equation with my value of 6 rad 3. I'm trying to figure out what the short side is. I want to get L. Notice, this one we can do by pattern recognition. Both sides already have a rad 3, and so therefore the only number that could go in front for L would be 6 in order for those two sides to match. So L is 6, my side across from 30, and so my hypotenuse, I need to double that, so I'm going to do 2 times 6, which means my hypotenuse would be 12. Okay. For number 4, I'm going to find missing angles first, 60, 90, 30. Across from 30 is L. Across from 60 is L rad 3. And across from the right angle, the hypotenuse is 2 times L. Another one where we have to start with the medium side, and we want to get L by itself. If you remember from the 45, 45, 90 examples, if you try to divide both sides by rad 3 in this one, might be your first thought, since we're multiplying L by rad 3, the opposite of multiplying would be to divide. If you do that, you're going to run into that issue where we have a radical in the denominator, and that's just bad news. We can't do that. So the way around that is I'm going to multiply both sides by rad 3, which turns the rad 3 into a 3. If I multiply this side, actually, you know what? Let me write it so I have space. Let's do the 6 on the left. That way you can see the rad 3 getting multiplied. If I multiply this side by rad 3, and I multiply this side by rad 3, I get 6 rad 3 equals, strategically I'm picking to multiply by rad 3 because rad 3 times rad 3 is just normal 3. So I get 3L equals 6 rad 3, and I'm trying to solve for L. The opposite of multiplying by 3 would be to divide by 3. So I'm going to divide both sides by 3, not rad 3. 6 rad 3 over 3. And notice those coefficients in front. 6 divided by 3 can be reduced. That is just 2 rad 3. 6 over 3 becomes 2. And so L ends up just being 2 rad 3. And if I double that to get to my hypotenuse, I need to multiply that by 2. 2 times 2 rad 3. All I need to do is multiply 2 times 2 in front. 2 times 2 would be 4. And so this hypotenuse would be 4 rad 3. Okay, we're not doubling the number under the radical, we're only doubling the number out front. For number 5, we have a 30 and a 90. In order to add up to 180, the top angle has to be a 60. Across from 30 is L. Across from 60 is L times rad 3. And my hypotenuse is 2 times L. So in this one, the hypotenuse is my starting point. I want to get L by itself. I have 2 times L equals 10 rad 5. To get L by itself, I'm going to divide by 2. And I'm going to simplify. 10 divided by 2 in front can reduce to 5. So I get L equals 5 rad 5. So there's my short side, 5 rad 5. To get to the side across from 60, I need to plug in L here and then multiply by rad 3. The side across from 60 is always rad 3 times the short side across from 30. So in this case, across from 60, my medium side, L, I'm going to substitute in 5 rad 5, but then I need to multiply by rad 3. And so rad 3 times rad 5 can turn into rad 15. So this becomes 5 rad 15. And 15 has no perfect squares that can be pulled out of it, so that just stays as 5 rad 15. Okay. Okay. There's some extra practice problems for you at the end of the notes. I have these on my answer key to check your work. Give these a shot first, and then check your answers using the key. Once you're done with that, you can move on to your homework assignment. Happy mathing.